Welcome to the final round of your NVIDIA software engineering interview. We want you to solve clone graph. In a reference to a node in an undirected graph. Each node contains a value and a list of neighbors. Your task is to return a deep copy of the entire graph, actually going and recreating each and every node. How would you approach this? Easy, I'll just traverse the graph and for each node, create an identical node with the same value and neighbors. What's the problem with that? In a graph, nodes can be revisited through cycles. If I don't track what I've already copied, I'll either duplicate nodes or fall into an infinite recursion. So how do you handle cycles and shared neighbors correctly? You need a way to remember which original nodes we've already cloned. That way, every node is copied exactly once. Describe that idea. Maintain a map that maps original nodes to the clone nodes. And I'll start by doing a depth first search on the first given node. The first time I see a node, I'm going to create its clone, then add the mapping from the original to the clone, then iterate through its neighbors. If the neighbor hasn't been cloned yet, meaning it's not in our map, I'm going to recursively clone it and call depth first search on that neighbor. If it has, I just reuse the clone version in our map, add it to the current node's neighbors. This guarantees that cycles are preserved and no node is duplicated. So what's the role of that mapping? It acts as both a visited set and a lookup table. It prevents infinite loops, ensures every edge in the original graph points to the correct clone node. And the complexity now? The single depth first search call. O of n time, where n is the number of nodes in the original graph. We also use O of n space for the mapping of the original to the clone nodes. Pretty clean if you ask me. Perfect, you got the job.